Hi, welcome to Math Master. This is Saritha. Today we will learn about similar right angle triangles theorem. What is a similar right angle triangle theorem? We'll see the statement first. So you take one right angle triangle. See, this is a right angle triangle. In this angle B is equal to 90 degrees. So you draw one perpendicular from the vertex at the 90 degrees from this vertex to hypotenuse. See, you draw one perpendicular through the vertex to the hypotenuse. Then this perpendicular, so this we call is a point D. So this perpendicular, this BD perpendicular, divide the hypotenuse into two parts, that is AD and CD. Yes. So what it is dividing, this perpendicular dividing the triangle into two more right angle triangles. See, this ADB is one right angle triangle. See, this is 90 degrees, right? And see, BDC is another right angle triangle because this is 90 degrees. Yes, this perpendicular is dividing the triangle ABC into two more right angle triangles, in which those two right angle triangles are similar to each other, as well as each of these perpendicular, each of these triangle is similar to the original triangle ABC, which is nothing but this triangle ADB is similar to triangle ABC, as well as this triangle BDC is similar to the triangle ABC. So this is the statement of the right angle triangle theorem. Now we will conclude some statements from this theorem. Okay. See, this is 90 degrees. This is 90 degrees. I am considering, I don't know what is the angle here. So I am taking this is a theta. Okay. So this is theta. This is 90 degrees. What about this angle? So if you sum up these three angles, it must be 180, right? So this is obviously 90 minus theta, isn't it? See, you check sum of these three angles, it is 180 degrees. Similarly, you write angles in this triangle. Okay. So what happens to this angle? See, this is total 90 degrees. So we have taken this angle as a theta. What is left? 90 minus theta. Because if you add these two, you should get 90 degrees. That is why this is 90 minus theta. What about this? See, 90 plus 90, 180 minus theta. If this is theta, then which is equal to 180 degrees. Okay. So this is how we write angles in the triangle. Now see, these in the statement itself, they are saying these triangles are similar to each other. This small triangle, the perpendicular divides the larger triangle into two right angle triangles, right? So what are those two right angle triangles? We will write here. So triangle ADB. Okay. So this is the triangle ADB, right? So which is similar to what? You while writing the similarity of triangles, I said you sequence is very important. You check angle A. What is the measurement of angle A? 90 minus theta. So you check which angle measures 90 minus theta in the other triangle. See whether D vertex or B vertex or C vertex. See here this B, it is measuring 90 minus theta. That is why you have to write B, because in the similar triangles corresponding angles are equal. See, this angle A is equal to angle B. Angle A in this triangle is equal to angle B in this triangle, isn't it? Next, check angle D. What is the measurement of angle D? 90 degrees. You check which angle measures 90 degrees in this triangle. See, this is also D. You write D here and check What is the measurement of angle B in this triangle? See, this is the angle B in this triangle, theta. Okay. So, which angle measures theta in this triangle? It is C, right? So, you write C. These are the similar triangles, similar right angle triangles. You check, triangle ADB is similar to triangle BDC. Okay. Now, one more statement is there in the right angle triangles theorem. What is that? Each of these right angle triangle is similar to the given right angle triangle, right? So, the small right angle triangle is similar to the given ABC right angle triangle. So, we'll see how it is. So, triangle ADB, right? Triangle ADB, which is similar to what? You have to check the angles. Angle A in the triangle ADB, what is the measurement of angle A? 90 minus theta. You check for this angle in the larger triangle. Where is 90 minus theta? You check. So this is a 90 minus theta. In the larger triangle also, angle A only measures 90 minus theta. So you write A here. What is the measurement of angle D? It is 90 degrees in this triangle. Where is the 90 degrees angle in the larger triangle ABC? It is B, right? So at the vertex B, it is 90 degrees. So you write B here. And similarly, you check for B angle. So it is measuring theta. So you check for theta angle in the larger triangle. Which angle measures? Angle C measures angle theta. So you write C here. Okay. So this is the way you have to check the similar triangles, because we have a sufficient condition, that is angle, angle, angle axiom. So from that we can say if corresponding three angles are equal, we can simply say they are similar to each other. So that is why we are checking all the three angles which are corresponding angles are equal. That is why we are saying those two triangles are similar to each other, as well as each of this triangle is similar to the bigger triangle. Yes. And you check this other small triangle which is BDC. Okay. So triangle BDC, which is similar to what? You check the angles. Angle B in the triangle BDC is what? 90 minus theta. Yes, you check 90 minus theta in the bigger triangle. It is A, right? So it is A. What about D? It is measuring 90 degrees. But the 90 degrees in the larger triangle is B. So you write B here. And C. What is the angle C in this smaller triangle? It is theta, right? So which angle measures theta in these three? C itself. So you write C here. So these are the similar triangles which are in the given triangles. Yes. Now, so these two are similar triangles. We know if the two triangles are similar, the sides are always in the proportional. Now we write the relation. What is the side AD is proportional to BD, right? So what is the relation? So this is 1 and this is 2 and this is 3. Okay. So from 1 we can write AD by BD. So you observe the sequence how to write. So next DB by next two sides, DB by DC, DB by DC. You can write either BD or DB, CD or DC. So that is for our convenience. And the next one is AB. Here BC. Yes, AB is divided by BC. Yes, as these two are similar triangles, we have concluded that the sides are in the proportional, corresponding sides are in proportional. That is why we have written this relation. So from this relation, if you take these two, observe AD by BD, which is equal to, so I am writing BD by DC. Okay. From this, we can conclude BD square, which is equal to AD into DC. AD into DC. So this is the one conclusion we have drawn from the first two parts of the right angle triangles, right? So what it represents? BD is what? Here BD is nothing but a perpendicular. So a perpendicular drawn through a vertex to the hypotenuse. So which square is always equal to product of the parts of the hypotenuse. Here AD is what? It is one of the part of the hypotenuse. What is DC? It is another part of the hypotenuse, isn't it? So that is the relationship between the perpendicular and the hypotenuse, parts of the hypotenuse. So what is the relation? The square of the perpendicular, which is equal to product of the parts of the hypotenuse. This relation is very important while solving the problems in this chapter. Okay, you try to remember this relation, and we will conclude three more relations from other triangles. Okay, so from, if we consider these two, we have drawn this. Okay, this is one relation, and we will conclude two more relations, which are from two. These two are similar triangles. From these two similar triangles, in this also corresponding sides are in proportional. So we can write a relation, that is side AD and side AB are proportional, right? So that is why AD by AB, which is equal to DB by BC, which is equal to AB by AC, AB by AC. Now you consider these two, AD by AB, which is equal to AB by AC. So AB square, which is equal to AD into AC. So this is one relation we can conclude from the two. Yes, AB square is what? Is one of the side square. In the bigger triangle, one of the side square, AB square. What is AD here? See, check. This is the part of the hypotenuse. What about the AC? Which is complete hypotenuse. This is AC. Yes. So, this relationship you have to remember. Okay. These four relations are very important in solving the problems. Okay. AB square is equal to what? AD, the part of the hypotenuse into hypotenuse. Okay. And the next, we take these two. So what are those? BD by BC, which are equal to AB by AC. So now we can write this BD into, this AB into BC, which are equal to BD into AC. So this relation is very important. You check, this is the relation between the two sides. AB is one side, BC is one side, BD is the perpendicular, AC is the hypotenuse. If we know the two sides and hypotenuse, we can find out the length of the perpendicular. So in that case, we need this relation. Okay, so this relation is also important. So next we will conclude one more relation from 3. So from 3, so these two are also similar triangles. So we can write this BD by AB, which is equal to CD by BC. which is equal to BC by AC. So what are these? From this you consider these two, right? BC square is equal to AC into CD. So this is one relation. What is represents? BC square, nothing but side square, which is equal to AC, the complete hypotenuse AC and part of the hypotenuse CD. Yes, if you consider these two triangle, so the part what we are considering, the part of the hypotenuse from this triangle. Okay, in that way you have to remember. Okay, so these are the four relationships you have to remember. Okay, this is about a right angle triangles theorem. Thank you.